Good day everyone, welcome back to our chemistry series. Today we'll be teaching separation techniques as a continuation of our last studies on element, compound and mixture. Separation techniques. Separation techniques are methods used to separate mixture into their individual components without changing the chemical nature of the substances involved. Separation techniques employed in separating mixtures makes use of the physical properties of their constituents, such as difference in solubility, boiling point, sublimation, rate of diffusion, rate of movement over an absorbent medium, or magnetic properties. Types of separation techniques. Now we have various types of separation techniques which we'll be treating one after the other. Now the first one we'll be treating, which is our number one, is magnetic separation. Now this method is used to separate magnetic substances from non-magnetic particles with the help of a magnet. It is applicable in steel industry and to remove magnetic impurities from tin ores. Basically it's just separating magnetic and non-magnetic material by using a magnet. Number two is sieving. This method is used to separate solid particles of different sizes. The particles are placed on a sieve with a mesh of a particular size. Particles smaller than the mesh size of the sieve will pass through, while bigger particles remain on the sieve. This method is used in mining. Now we have a single mesh system or a multiple mesh system which sorts different particles at the same or particle size at the same time. Below is a diagram of a mesh. Number three is sublimation. Now this method is used to separate solid which sublime on heating. This solid when heated change directly to the gaseous state without going through the liquid state. Examples are iodine, ammonium chloride, iron 3 chloride, sulfur and benzoic acid. Example, consider a mixture of iodine and sodium chloride. On heating, the iodine sublimes and reform as solid at the cooler part of the apparatus. The reformed solid is known as sublimate. Now number four is separating funnel. This method is used to separate immiscible liquids such as petroleum and water because they are non-polar and polar solvents respectively. Immiscible in this case means unable to mix evenly or form a single solution. To separate the two layers, a separating funnel is used. The lower denser liquid is tapped off, leaving the upper less dense liquid layer in the funnel. It is done in a setup as shown in the diagram below. Number five, chromatography. This method is used for separating mixture by taking advantage of their different rate of movement in a solvent over an absorbent medium. It is based on the principle that if a fluid containing a number of substances is allowed to pass through an absorbent medium, the different substances in the fluid may travel at different speeds and can be separated. Chromatography is used to separate dye in colored ink. It is used in medicine to analyze blood or urine. Industrially, it can also be used to identify the components of petroleum. There are different types of chromatography. These are 1. Paper chromatography, 2. Column chromatography, 3. Thin layer chromatography, 4. Gas chromatography, and 5. Ion exchange chromatography. The commonest and the least complicated method is the paper chromatography, which uses filter paper as the absorbent medium. Number 6, we have decantation. Decantation is a simple laboratory and industrial process which used to separate mixture of immiscible liquids like oil and water or liquid and a solid like muddy water. For the immiscible liquid separation, water and oil are two liquids that have different density, so they form two separate layers when mixed together. Water being denser settles at the bottom and oil flows on water. The separation can be done by pouring oil out into a different container, leaving behind the denser water in the original container. The liquid-solid separation separates insoluble solids from liquid by first allowing the particles to be settled via the action of gravity, and the upper layer is poured off, leaving behind the denser solid. This method is quick but inaccurate because some of the solid is lost. The next separation technique we are discussing is filtration, which is our number 7. This method is used for separating an insoluble solid for a liquid through the pores of a filter paper. The liquid which passes through the filter paper is called the filtrate, while the solid particle remaining in the filter paper is called the residue. Filtration is mostly used for suspension like chalk and water. Water purification plants and brewery industries use filtration to remove solid particles from liquid. Centrifugation. Centrifugation is a technique used for the separation of particles from a solution according to their size, shape, density, viscosity of the medium, and rotor speed. The particles are suspended in a liquid medium and placed in a centrifuge tube. The tube is then placed in a rotor and spun at a defined speed. The spinning causes the solid particles in the suspension to be thrown to the bottom of the test tube. They settle there while the clear liquid separates out as an upper layer, which is then decanted. In hospitals, blood samples are centrifuged to separate the blood cells from the plasma. Number 9, evaporation. Evaporation is a method used in separating a dissolved solute from a solution by heating the mixture to dryness so that the solvent escapes. Example: salt solution is poured into an evaporating dish and heated gently over steam bath or sand bath on the Bunsen flame. The water evaporates and the salt is left behind. Evaporation is used in salt making industries. Number 10, crystallization. Crystallization is a separation technique used to separate a dissolved solid that crystallizes from a liquid solvent. It forces the solute to form high pure solid crystal by altering the solution's temperature or concentration until the solute precipitates out. The solution is concentrated by evaporating a portion of the solvent. As the saturated solution slowly cools, its capacity to hold the solute decreases, prompting the molecules to bind together and form pure crystals. The resulting crystals are separated from the remaining liquids in bracket called the mother liquor via filtration, washed to remove surface impurities, and dried. Fractional crystallization. Fractional crystallization is a method used to separate a mixture of solid substances based on the difference in their solubility. The mixture is first dissolved in a stable hot solvent to form a concentrated solution. As the solution is allowed to cool slowly, the solubility of the components decreases, causing the substance that becomes saturated first, usually the least soluble under those conditions, to crystallize out of the solution. Number 11 is distillation. Distillation is a separation technique used to separate components of a liquid mixture by a process of heating and cooling, which exploits the difference in volatility of each of the components. It is used to recover a solvent from a solution, that is, process of vaporizing a liquid and then condensing the vapor. Fractional distillation. Simple distillation cannot be used to separate a mixture of two or more miscible liquids. Fractional distillation is used to separate a mixture of two or more miscible liquids with relatively close boiling point into its component fractions. This method is used to separate crude oil or petroleum into its component fractions such as natural gas, petrol, kerosene, gas, heavy oil, and bitumen. It is also used to obtain pure nitrogen from air. The main difference between a distillation and a fractional distillation setup is the addition of a fractionating column to the simple distillation setup. Number 12 is precipitation. Precipitation is a separation method where an insoluble solid called a precipitate forms when two aqueous solutions react together. A typical example is seen when a solution of potassium bromide is added to the solution of silver triazole-95 and a soluble potassium triazole-95 and an insoluble silver bromide are formed. The reaction is shown below. The precipitate can be separated from the solution by filtration. We have a table that lists all our separation technique discussed, what is separate and the properties it works on. Now for the first, we have sieving, which is used for a mixture of solid with different particle size, and it works on the principle of difference in particle size. The next is filtration. Filtration is used for insoluble solid from a liquid. It works on insolubility and particle size. The next we have evaporation. Evaporation is used to separate soluble solid from a solution. It works on volatility of the solution. Now we have crystallization, which is used for pure solid from solution. It works on solubility, and in bracket temperature at which solute crystallize. Then we have fractional crystallization, which is a mixture of dissolved solute. Same thing with crystallization, these are the different solubility of solute in the same solvent. The next is precipitation, which is used for insoluble solid formed from solution. Formation of an insoluble solid during a chemical reaction is the properties it which is worked on. Now we have simple distillation. It is used for pure liquid from a solution. Now it works on difference in boiling point. We have fractional distillation, which is a mixture of miscible liquid. It's still the same thing, difference in boiling point of the liquid. The next we have separating funnel. It is used for immiscible liquid, density difference and immiscibility. We have chromatography. It is used for soluble substances in a mixture. Now, a different rate of movement due to solubility in mobile phase and attraction to stationary phase is the principle with which it works. We have magnetic separation, which is used for magnetic from non-magnetic materials, and it works on magnetic properties. We have sublimation, which is used for sublimable solid from non-sublimable solid. Now, it works on the ability of a substance to change directly from solid to gas. The last is centrifugation, which is used for suspended solids from liquid. Now it works on the density differences, that is settling under centrifugal force. We have some examples we will be using as revision. Our first example is from 2005, and it states that a solid can be obtained from its saturated solution by, and we're given the option. Now we know that a solid can be obtained from its saturated solution by crystallization, so the correct option is B. The next example states that, which is from 2007, it states that which of the following method can be used to separate a mixture of two miscible liquid with different boiling point. Now the method used to separate two miscible liquid with different boiling point is distillation, and the correct option is B. Our third question is from 2013, and it states that the separation of petroleum fractions depends on the difference in their. Now separation of petroleum fraction use distillation, which depends on the difference in boiling points, and the correct option is D. We have another question from 2014, and it states that a compound U melts at 82 degrees centigrade and boils at 130 degrees centigrade. If U was found to be insoluble in water, a mixture of U in water could best be separated by, we're given the option as A. chromatography, B. sublimation, C. filtration, and D. the use of separating funnel. Since it is insoluble in water, the best option is filtration, and the correct option is C. We have another question from 2016, and it states that list three methods of separating a solid from a liquid. Now the method of separating a solid from a liquid are filtration, evaporation, crystallization, and decantation. We have another question from 2016, which is going to be our last question. It states that what difference in physical properties enables the separation of mixture by 1. simple distillation, 2. paper chromatography, and 3. fractional distillation. Now simple distillation uses difference in boiling point. That's a physical property that enables simple distillation. For paper chromatography is the rate of movement of a solvent over an absorbent medium, while fractional distillation, same as distillation, uses difference in boiling point. Here are some exercises for you to try your hands on at home. And for more insights on this topic, you can check out the chapter 2 of our Hidden Facts Chemistry textbook. You can get the hard copy in bookshop, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.